which is a profiler that offers an intuitive visual representation of the execution. And make the relation between the time spent, the method, and the number of times the method has been executed. I mean, what you had like with the traditional code profiler, in the case Pharo, but this is exactly the same thing in VisualWorks, is to have something like this, textual description of what happens, and you have like the indentation to say, that tells about the nesting of the code. So what we have with your profiler is something like this. So this is a visual representation of the execution. So you have like the big squares are classes. So here you have 1, 2, 3, 4 classes. Inside you have the methods. So here in this class you have 3 and 2, you have 5 methods in this class and a root. And each method has shape and a color that differ from the other one. And the height of a method is the amount of time spent in the method. So here you see that there is a very, very tall method, much taller than the other one. And it means that at execution times, you spend a great deal of time in that particular method. The width tells you the amount of time the method has been executed. This method here is very thin. It means that it has been executed once. And over there, like you see some very tall and thick methods. It means that you spend the CPU spend a lot of time in those methods here, and those methods has been executed like many times. The color means the number of different receivers the method has been invoked on. Not only on the same object, but also on how many different objects the method has been executed. And yeah, so if you right-click on a method, and you have a menu, and then you may have like to get a different view on the method. So now here we see that the code graph of the method, the code graph of the execution, and we do not see the classes anymore, but we see the code between different methods. So here at the top of we have the tall and thin methods that execute a lot of different methods. And the colors here plays a very important role. The gray, this one, means that the method does a side effect. And the yellow means that the method does not do a side effect. It means that it doesn't change the state of the object that receives the message. And this is a very important piece of information I'm going to show you later. Yeah. So now we show you a bit of
Alexandre, just to clarify, it means it doesn't have a local side effect on the receiving object.
Yeah, it means that the state of the object
was not changed, but not of any of the message sets. Obviously, it can cause side effects elsewhere.
Yeah, but so we use the heuristic that if a method doesn't change the object, but then once the method called by this method change, then it gets propagated. We are really trying to keep track of the side effect. This is really important piece of information if you want to introduce caches. Okay, so here this is implementation in VisualWorks. So here this is how I can invoke Kai. So here I have to create an instance of the Kai profiler, and here I have to say the number of times I want to repeat the code I want to profile. This is related to the previous talk. And here this is the piece of code that I want to profile. So this is a piece of code that involves Mondrian. This is interesting because I'm displaying the profile as the visualization in Mondrian. So I'm profiling Mondrian in Mondrian. Yeah. And here this is where the code can be found. What are the namespaces, the packages, the class category that I have to instrument. And here I say visualize. So currently there is no really GUI to launch Kai, but it's going to come very soon. If I do that, then it takes about 20 seconds, and then I will have the result like this. So here this is, description of what happens. So here I spend like 43 milliseconds to execute one iteration, the number of classes, number of methods, and so here this is, you see that there is a method called abstract figures, this one here. It has plenty of method inside. So we can see that some very tall method. You mean that I spent a lot of time in this particular method, but this method has been executed many times. This one, I didn't spend that much time on it, but it has been executed many times. I put the mouse here, I see the information. But this access of until has been called like 18,000 times. And yeah, so in blue here, those are the methods that are contained with the block and profiling. So this is the entry point of the code. So I can select one method, and I can do right click on it. I can do like the time profiler report. So for some people who cannot really go away from traditional profiler, and you still have the information. This is something very important, like to make sure that people don't get lost. And I pick a method, and I see like what are the outgoing invocation methods. So here I see like not only structure in terms of classes, but what is the complete call graph. So here you see like many tall methods. This method, it means that we spend a lot of time in this method. These methods are wide. It means that it has been executed, just on one object. And we can also keep track of the side effect. So all these gray methods are doing a side effect. Here there is a yellow method that doesn't do a side effect. Doesn't change the state of the object that receives the message. And here we have this particular situation. Yeah, so that's for the brief foundation of Kali. So now we're motivated with the choice that we made when on the visualization itself. Okay, so let's get back on the structural profiling blueprint. So this is a visualization that I obtained from the application Mondrian. And I was a bit surprised that like so many of these big squares, and one of them is bounds. Bounds simply return the bound inside of the class rectangle that describe what is the outer bounds of a graphical object. I was a bit surprised that this method takes so much time. So by doing a right click on this tall method here, I get like this whole graph, and I see that this bound here is a method that doesn't do side effect. So bounds takes a lot of time. It has been executed many times because it's thick and it's very wide, and actually it doesn't do a side effect. So right click on the method, and I can get the source code, and this is the source code of the method bounds. Since the method has been painted in yellow, then introducing a cache might be a good thing. In that case, it is. So I augmented the class MOGraph element with an instance variable called bounds cache, and I did like this first line of code. I say if bounds cache is not needed, then I return the value of it, and then I initialize bounds cache at the end. I mean, just these simple 2 lines, I gain a lot of in terms of execution time. So this is above part. This is the result of the profile without the cache, and below this is with the cache. And in CFL, you see differences that there is in the 2 profiles. So this has been translated in a gain of 43%. Like for the code graph, then we see also differences. So below there is a method bounds, and bound has been significantly reduced to something like much smaller. So I mean that the execution time is much shorter. And actually, we found that fairly cool. To say that when there is big yellow method, then we can just introduce a cache. So we repeated the things, and this is Mondrian, but a different thread. This is the UI thread, not the profiling. Before it was the logical thread, and this is the UI thread. And we see at the bottom like some thick and tall yellow methods. So we started to introduce some cache. There is the method absolute bounds that has the same symptom as the bounds before. then we introduce the cache, then it's suddenly reduced, and like below there's still a method that was too thick and tall for my taste. We change one of the code inside, and then the profiling the code graph as this shape here. It means that at that level, it's very unlikely that we can gain much in terms of execution time. So yeah, any question?
Just because the box is yellow doesn't necessarily mean that introducing a cache variable will speed it up. No, it will speed it up, but now you have to manage that cache variable, and sometimes you'll have to clear it.
Yeah, so this is not really, this is a difficult question to answer. But I do agree, it's just an indication, and of course you need to be careful on.
You still have to carefully look at it.
Yeah, indeed. There is no magic, there is no magic. But this is like a very good indication that without that, it could be pretty difficult to find. That's why having such, things might majorly change the whole game. Any question? More question before I move to the second profiler? Okay, so one way to get, to make sure that you're not breaking the whole system by introducing cache is to have a very good, set of unit tests. And this is what the second profiler is about, assessing the coverage of your test. The traditional code coverage tool, they have binary view of the word. Either the method or statement or method code is covered or it's not. It's one or the other one. And it means that which method, which component is covered, but you don't know whether it's well covered. And if something you're not covered, you don't know where you should put the effort in covering first. And this is what we're going to talk about. Just answering the question, which method should you test first? In order to increase, the test coverage, this is, not an easy question. If you take some existing tooling in Java, then you have, the list of methods that are not covered. So which one should you pick first? It's not something easy to do. So so we have produced a new test coverage tool. I'm not sure whether there were already one in VisualWorks. So in Pharo there were one, but it was a bit shaky. So we made a new one, and I hope you're going to like it. So similarly, then for the previous profiler, then we use visualization, to convey, to carry out the result of the profile, of the test coverage. So same thing than before. So big class, big square is a class, and inheritance is indicated with the age between classes. And here we have C1, which is a superclass of C2. Within the class, you have the methods. And so in the class C1, you have 5 methods. And the color of the methods tells about whether the method has been invoked or not. So you obtain this graph, you obtain the visualization after running a test. So the age of a method is the cyclomatic complexity. It means that taller the method is, more complex it is. And as an implication, it means that you may want to test it first because it's a complex one. And the width is the number of different methods that call this particular method, and the color is the number of execution, the number of time method has been executed. Okay, so here we have a version running. We have a version running in Pharo. So here this is the result of profiling, and we have the same thing running on VisualWorks. This one here. Yeah. So you run the profiler that way. You say that you run Pharo on the packages for which the name being is Mondrian, and then it will visualize. You just have to have this one line to obtain the following graph. This one. So here you have a short summary of what you want to profile contain. So you see there is 118 classes, there is 1,700 methods, there is the coverage in the average, like 65% of the method have been covered by the test. And there you can see like a lot of unit tests. Unit tests are painted in green. And here you can see the different hierarchies. So here you have like a monster, like abstract figure. I mean, this is the root, Mondrian, in the visual co-expression of Mondrian, this is the root of the different graphical elements you can have, and this root often is complicated. So here you can see that there is a lot of red, and there is a bit of red versions, and those are the methods that are not covered. In gray, those are the methods that are covered, and in black, those are the methods that execute a lot of time by the test, and probably were covered. And I guess I can see like can browse the different classes and hierarchies of the systems. Yeah, so Mondrian is a large application. So we'll pick one example. Let's say this one, Sugiyama layout. This is method, no, this is a class that implement the Sugiyama algorithm. This is the one used to order, this is a graph layout that minimize the crossing between the edges and so on. So we see that there is, many methods here. There is this one called do execute, and do execute called many methods here that belong to the same class. And those methods are not covered. Some of the methods are covered. So we pick one of them called sort block. I click the method, I right click, I can focus on it. And here I can see I can access the source code of the test that tests this particular method here. So now if I want to increase the coverage of Mondrian, then I have to write some code that will call this method here. So I know Mondrian a bit, so I will comment this piece of code that will simply create a visualization, Mondrian, and then do the layout of a tree that I will create from all the classes of the class of collection. Okay, so now I commented this piece of code. Then I need to run again the test of Mondrian to obtain a new profile. Do it. Runs all the tests of Mondrian. And then I see the Sugiyama layout, which is there, which now is great because using my test method, and I put the code that executes this piece of code. Yeah. Okay, as I demonstrated, Pharo is quite useful to do some incremental change on the test. You can, in a very stepwise way, you can increase the coverage of your tool. There is 4 patterns that we have identified. So there is a number of methods that are not connected, that are just isolated. And then when you want to increase the coverage, then you need to write tests for each of them. There are also some methods here that are not covered, that are called method that has been covered already. Then you need to write tests of those guys or increase the coverage of the test that call this guy to call those guys. And this is the most very interesting picture because here I have a lot of methods and this method are all connected with them. It means that those are the roots of the flow that I have here. It means that if I were to test, call this method, this one, and then hopefully everything is going to be like great. So the assumption behind this pattern here is that if I test this method here, hopefully I can get a ripple effect. That by calling this method, hopefully I can call also this method. And here this is an example of the Moose class hierarchies. So that was before we do the, for testing effort, and then that's at the end. Something that we have found out is that this relation is pretty good. We believe in assessing the test coverage, but also like to tell about how complex the code looks like. Because you have a lot of boxes, a lot of edges, then it really gives like a sense of whether the code is complex or not. On the left-hand side, this is a class in the MetaChilo browser, and about this is the root of hierarchies. And then, like when I got the blueprint of this class, I really found this class a bit too complex. There were some very tall methods in the high cyclomatic complexity. So we wrote some tests for this class, and then we cut some method down, and we removed that code, and then we obtained a simpler version on the right-hand side. And here this is a different version. A second class that was, complex, and then we removed some of the complexity to obtain something like below. Yeah. Any question?
Hey, Alexander. I'm sorry to ask about something not totally directly related to profiling or coverage, but when you were scrolling horizontally through the very large output and to find the new level of coverage, is there a quicker way to find the element you were interested in by, say, like searching by keyword or something like that, or to scroll straight to it, just for the usability of Mondrian?
Yes. Okay. So this is an important point. Currently is not supported. But tomorrow, hopefully, I will demonstrate the next generation of the visualization engine called Russell, where it's much simpler. Okay, Mondrian was complex because you have graphical component which is embedded within the hosting language, component with some scroll bars, and then you need to change the scroll to get first access to the scroll bar, change them, and to make sure what the user is currently seeing. But we have something like much simpler. Hopefully, I will be able to demonstrate tomorrow.
Okay.
I think, our use of this right now, in a couple of our developers, initially when the visualization comes up, it's quite intimidating because they see all these rectangles and the invocation lines. But and so initially one of the things we asked was vector to the method that I profiled, so that I can at least start from there. But what we also find is that our guys, sometimes they don't even use it for profiling. They actually use it for reverse engineering software that isn't theirs, because they can find out what the call graph is. So it's kind of, one of the guys said it's like a 90-degree flip UML sequence diagram, where he can take a look at things and find out how things interact. So it's sort of as a side effect of giving us some reverse engineering tools.
It definitely looks like a tool that would reveal things that you didn't even expect.
Yeah.
Okay, so we're slowly reaching the end of my presentation.
There was a question.
I want to ask you, how do you find it in practice on real-world projects? And I'm sure you'd be able to answer this as well. Is it really manageable? Did you get too much information that you can't?
Yes. Sometimes our guys have analysis paralysis. They're looking at this massive chart and they don't know where to begin. But one of the things over the next year is for us to work with his team to try and actually, the first thing we did in August when we saw this was we realized, okay, there's some potential for this, but what we really want to do is apply this to production code with a production team. And so over the next year, we're going to work with them to try and integrate it into the browser and get it to a point where our engineers navigating.
It's a very interesting project, and I'm interested to see how it works with a real production system,
I mean,
with lots of complexity.
Another thing that we're hoping to do, of course, is that we want to keep it open. It's available at the Syncom Public Store for any device to play with, and we're hoping that other production teams can feed back to you guys as well to tell them, what's good and bad about it.
Yeah, you talked about how you made this, especially this chart, it helped to make the code easier and less complex. Do you have any plans to say include other code metrics like I said, cyclomatic complexity? And so the tool tells you afterward, like, this is a good spot that you should refactor and the code will be easier?
We are really open and we can introduce new metric, but from my experience, as it often happens with research, ideas that that could be very good for the researcher, maybe for a smaller community, but then for the blind human beings, it might be complex to understand what's going on. So we really try, spend a great deal of effort in keeping the things simple. So if there is a better metrics, why not? We have used cyclomatic complexity, but maybe the number of lines of code, is well good enough. We don't know. We need to get more experience on that. Yeah. So to complete, I would say that there is, the Spontac way of programming is really amazing. It's really amazing. But there are some niches where I think that we are not as good as we could be and should be. So profilers, I discussed today with some guys from Resource Station, and they say that the profiler we have, has enchant for the last decades, and this is the same thing in Pharo script. This is the same thing in Visual Works. So there is profiling and debuggers and testing tools. There is really something new that can really do. So I haven't really talked about debuggers, but at the ITSE, International Conference on Software Engineering, we have worked on. I will present latest work on object-centric debugging, which is really cool. It's a new way of debugging software. So yeah, but this is really something that we really need to be more, to get better innovation on that. So Kai and Pharo are just the beginning. It's really the beginning of what something completely change the way that we are programming and really take the power of the object to its essence.
Why are there two Kai and Pharo? I didn't catch why there were two different tools.
Because they give different kind of information. Kai is about where the CPU is spending time on, and Pharo is about what my test what. What is tested
I'm
by
sorry.
what.
Okay, I see.
And this is a good question. Many people are saying, oh, why not, to just have one profiler? That would be simpler for the human beings. There's just one way, one thing that you should look at. But at the end, either your profiler, will tell you not enough, and you will be frustrated, or you will tell too much, and we don't understand what's going on.
So Pharo is a visual description of the success or failure of your tests.
Yeah, the test. And Kai,
Coverage.
this is about execution. The CPU times consumption. So, there is a lot of things that we are currently, have in back, such as a memory profiler, that I believe should be quite different from the code execution profiler. And yeah, so as a future work, we really have a lot of ideas. So profiling multi-threaded applications, this is something really tough to do. And I think some of the visualization we have, I think we can have something significant. Also, having the same on-code coverage. This is something that currently is missing, but we are working hard on that, how to get, a particular line is covered by what? Which test called that particular line? This is something valuable. Also, having something like a continuous server integration, this is something that is really missing. I discussed that during the coffee break. There is this cruise control of Visual Works. There is Jenkins that is intensively used by the Pharo community. Yeah, this is a good start. But if you really step back and say, no, there is much better I can get from the continuous integration. I mean, Mondrian had the following problem 2 years ago, such as I introduce a cache, I get like about 30% of the execution time. Mondrian 2 years ago was 30% faster. And then, like that was been 2 years ago, and then this 30% somehow seemed to have vanished. I'm not really sure why, there have been many contributions, but where this 30% went? And this is like a very tough question. Currently, there is no solution to answer this, that particular problem. But we have like a number of things that to answer this, to work on that. Also, like something like which is really quite new. Also, like in the research, not only from distributed from research, domain-specific profilers. And this is something like a completely different way of seeing the execution of the code. Currently, we're still doing like, method has been executed so many times. This is what the CPU spends so much time in that particular method. But at the end, it's not what I want to have. I want to know like how many times my object has been refreshed. How many times, how many nodes per second I can display on Mondrian. Those kind of questions, more at the, at the level of the, closer to the domain that you are very interested in. If you're dealing with web, HTTP serving, then how many requests per second? This is the thing you're really interested in, and not how many times it methods, how many milliseconds I spend in a particular method. This is very different level of abstraction, but this is very, very tough. Domain-specific profile is something new, and it's coming. It's slowly coming, and most of the people have been working on that in a very ad hoc way. So we have produced a framework that works well, which is very easy to write a domain-specific profiler. And yes, thank you very much. So this is what I want to say. And so there is SPY. SPY is the bundle that contains all profilers. So on Simcom Store, you can just look for SPY, and then you can install it, and then you're going to have Kai and Pharo for free. And everything is under the MIT license. There is also a Pharo version that you can find on Quick Source. And we make sure that our code can be ported to different smartphones. So if some of you are interested to see like a profiler on their smartphone, then we should discuss, and we are pretty sure that we can get something soon. Gemstone, association, I don't know. So there is a bit of documentation on objectprofile.com. This is a website. There is a screencast. There is a screencast that we have put online yesterday evening. So yeah. And yeah, so if you try that, maybe that you find some bugs. I mean, there is a great deal of advanced technology involved into that. You have to do like some profiling framework, code instrumentation, sampling execution, complex graphic rendering. So maybe there are some bugs. We are currently working on that, and we will be very, very responsive if you find the bugs. So this is something very important for us. So I really would like to thank you, Stig, Chris, also from LAM. Without him, I won't be here today. And also I would like to thank you, all of you. I mean, usually I'm, more, familiar to the academic conferences, and this is the very first time for me where I'm in an industrial conference. So I really would like to thank all of you. Yeah, thank you.